All right, guys, it's virtual day number 11, Friday, March 27th. We're starting with one a day now. We're doing chapter 3.3, polynomial functions and models. Make sure you're keeping up with your practice and homework. Even though I'm not there to go over them with you, if you have a question, I'm happy to video going over one of them. And I'm uploading my key for you. Remember, I'm only taking grades on quizzes and tests for as long as we're doing virtual days, and I'll upload the key to the cumulative homework on the review day. So just let me know what you need from me. We are determining whether or not a polynomial is a function is a polynomial. So a polynomial has the form of this, and all this means is it has a coefficient and an exponent, plus a coefficient of x and an exponent, and it goes all the way down into a constant. A sub 0 would be your constant, where a is a real number, so your coefficient has to be a real number, and your exponent has to be greater than or equal to 0, and it has to be an integer. So the degree is going to be the highest power of x. So if you've got this one, we have our real coefficient and we have an integer exponent that is greater than 0. So this is a polynomial, and this is degree 4. This one, remember that when you have a radical, it's written as power over root. So this is the same thing as x to the 1/2 power. So this is not a polynomial, because that is not an integer. 1/2 is not an integer. Here, this is not a polynomial, this is a rational. Zero, that is a polynomial. It just has no degree. Zero is a no degree. And then a constant, this one is a polynomial. It is just degree 0. Because this is like saying 8x to the 0 power, anything to the 0 power is 1. So that's why that works that way. And then this guy, this is a polynomial. To find its degree, you would have to get your leading coefficient all the way out after you FOIL this out. So ignore that, FOIL this out. So that is negative 2x cubed, x squared minus 2x plus 1. And all you care about is the leading coefficient here, so I'm just distributing here. And you would get equals negative 2x to the 5th plus some other stuff. So I'm 5th degree. Here is a nice table with the classification. And a polynomial function, f is a polynomial function and r is a real number for which f of r is 0. Then r is a real 0 or root or x-intercept of f, and r is an x-intercept. X minus r is a factor of f. So you've done this in Math 3. This should just be a review, but we're going to go through it. Please press pause if you need to. Finding a polynomial from its zeros. So we have a third degree, and then we're given these zeros. Remember, all of our roots can be written as x minus c or x minus r for roots. So what we've got here is x minus negative 3 or x plus 3, x minus 0, and x minus 5. So I'm just going to reorder this a little bit. We've got x times x plus 3 times x minus 5. When it says to find the polynomial, it wants you to go ahead. This is factored form. It wants you to go ahead and FOIL this out to get to standard form. So I'm going to distribute my x first. I have x squared plus 3x. And then I'm going to FOIL these out. So I get x cubed minus 5x squared plus 3x squared minus 15x. Combine your like terms. And this is your polynomial. You can say y equals, f of x equals, whatever, but that's your polynomial. Then it wants you to graph it on the calculator. This is a good way to just kind of check your zeros and make sure that you've done it all correctly. So x cubed minus 2x squared minus 15x. Oops, sorry. I should have an x-intercept at -3, at 0, and at 5, and I do. So then when something happens more than one time, or the power of your factor, that is called the multiplicity. If it's an even multiplicity, and this goes down here a little bit. If this is an even multiplicity, so if we have x minus 2 squared, then that means it's just going to touch. It's going to be a maximum or a minimum at the x-axis. If it's an odd multiplicity, it's going to cross through the x-axis. So just identifying those zeros in multiplicity, we're going to use the zero product property to find our zeros. So we have x minus 2 equals 0. So we get x equals 2. This is to the first power, so this is multiplicity 1. This one, x plus 3 equals 0, so x equals -3. This is to the second power, so this is multiplicity 2. And then that last one, x minus 1/2 equals 0, x equals 1/2. So the fourth power is multiplicity 4. This one would cross through the x-axis. This one would touch, and this one would touch, because these are even multiplicities, and that one is an odd. So now I'm going to use this to find my x and y intercepts and my multiplicities to find and to graph. So I've got here, I've got x squared and x minus 2. So x squared equals 0. That means that x equals 0. That is multiplicity 2. And x minus 2 equals 0. X equals 2. That is multiplicity 1. My y-intercept, if I were to FOIL this out, or I'm sorry, distribute this, I'd have x cubed minus 2x squared. There's not a constant here, so my y-intercept is going to be 0. This is an even multiplicity, which means it touches. This is an odd multiplicity, which means it's going to cross through. To graph this guy on your calculator, I'm just going to graph the original. And you see that it touches here and it crosses through there. So then I'm just going to sketch a little graph real fast. We're touching at 0, crossing through at 2, something like that. Graph of a polynomial function, degree of f is n, it's the highest power. The number of turning points is n minus 1. So this was a cubic equation. So that means the directional, so whether it's going, if it's growing, if it's decreasing, increasing, decreasing, that will turn at n minus 1, or your degree minus 1 places. So we had 3, so this one will turn at a maximum of 2 places. It doesn't have to be 2, but it's a maximum of 2, and you'll look at your graph to see what it is. Even multiplicity touches, odd multiplicity crosses. Between the zeros, it's either going to be above or below the x-axis. And the end behavior, we're just looking at our leading coefficient and our x with our highest power. So this, I'm sorry, should have printed on the other page. So I'm going to copy that down here. So we have f of x equals x to the 4th minus 2x cubed minus 8x squared. So this guy, I'm going to factor as much as I can. They all have an x squared in common, so I'm taking that x squared out. I'm left with x squared minus 2x minus 8. Then I'm going to factor this trinomial. I need factors of 8 that add or subtract to give me 2, 1 and 8, 2 and 4 to get -2. Then my 4 needs to be negative and my 2 needs to be positive. So I've got x squared, x plus 2, x minus 4. You can do this when your leading coefficient is 1. If your leading coefficient is something other than 1, you need to use the box. For the most part, it's your GCF will take your leading coefficient out with it. So my x-intercepts, set each of these equal to 0. You get x equals 0, 2, and 4. 0 is multiplicity 2, and 2 and 4 are multiplicity 1. My y-intercept, I did not have a constant here, so it's just 0. We will cross the x-axis at x equals 2 and 4, and we will touch the x-axis at x equals 0. Your end behavior, all it is asking you for with this is going to be your leading coefficient and your highest power, your x with your highest power. So this is going to resemble x to the 4th. We just want to know the power function that your polynomial resembles. Then we're going to graph it. We're going to graph it on my calculator first. I have x to the 4th minus 2x cubed minus 8x squared. So you can see what's happening here. We have 1, 2, we're going to have a third turning point down here, 3 turning points. And then what it wants you to tell me are the values there, the vertices. So I'm going to adjust my window a little bit so that I can see that last one. I'm going to adjust it. I need my y minimum to be lower, so I'm going to say negative 20 and see if that helps. Not quite. Adjust it again. 30. Wow, it's really down there, which is fine. There we go. Okay, so now we can see it. I'm just going to find each of these points. So second trace, I'm going to find my minimum first. My first one over here is a minimum. So left bound, right bound, inner. And you get negative 1.4. I'm just going to round to one decimal place at negative 6.4. So negative 1.4, negative 6.4. Do it again. I know I had a touching at 0, so you can verify that using the maximum. Or you can just know that that's going to be a 0, 0. This here is times 10 to the negative 6 times 10 to the negative 11. So what this is 0.000001, which is 0. I don't know why these calculators round like that sometimes, but sometimes they do. So when you see that, that means 0. So we have the 0.00. And then our last minimum is down here. Left bound, right bound, inner. 2.9 and negative 45.3. And then we're just going to sketch our graph. We have 0, 0. We have this happening at negative 2. I'm sorry, all of this should have said negative 2. And we have one at positive 4. We're going to have a minimum at negative 1.4, negative 6.4, and I'm just going to estimate here because my 45 is so low. And then I have my maximum there at 0, 0, and my minimum at 2.9 and at negative 45.3. So this is what my graph looks like. Something like that. Two more. Number 6, x cubed plus 2.48x squared minus 4.3155x plus 1.484406. We're going to start with graphing this guy on our calculator. Obviously, this one is not going to factor. So we have x cubed plus 2.48x squared minus 4.3155x. Graph it. I need to adjust my window again, sorry. 2, 6. And I need to find my x and y intercepts. Right away, I can look at my equation and tell you my y-intercept is this constant, 1.484406. My x-intercepts, looks like I've got 2 of them, so I can trace. I need to find my 0 on this one. Which is negative 3.74. And this one is crossing, so it's a multiplicity 1. This other one looks like a minimum value, so I'm going to use my minimum feature here. Point 6, 3. So I'm going to say 0.63, 0.63. And that right here, 8.1 times 10 to the negative 12. So that's 0 point and then 11 zeros and then an 8. This is 0. Okay. My end behavior, this is going to behave like y equals x cubed. And looking at my graph, I have 2 turning points. I'm going to adjust my window so I can see this top turning point. My y maximum, I'm going to bring it up to 20. And that should bring that one there so that I can see what those turning points are. One of them I already got, and that was 0.630. That was a minimum here. And then my other turning point, I need my maximum point there. Which is negative 2.28, 12.36. And then I'm just going to sketch my graph. So I have my y-intercept at about 1.5. It's really close. My x-intercept's at negative 1, 2, about negative 3 3/4 about, and 0.63 here. And then I have my turning point, which is here, and at negative 2.3 roughly, and then 12.36. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 12.36, and a negative 1, 2, 3, so something like that. So my graph is going to look like this. Roughly. The last one for this week. The data in the table below represents the average fuel consumption for cars in gallons in the U.S. from 84 to 97, where 1 represents 84 and 2 represents 85, and so on. Draw a scatter plot on the calculator. So I'm going to go to Stat, Edit, clear out whatever lists may be in there, and I'm going to type this in. I'm going from 1 to 14. And then here I'm typing in my average fuel consumption. So to draw my scatter plot, again, your stat plot needs to be on, and then I'm going to hit zoom option 9 so I can see my, I'm going to go to my y equals and clear that out. Find the cubic function of best fit, so that is stat calc option 6. I'm going to write this here. Y equals 0.23x cubed minus 3.66x squared plus 10.24x plus 496.07. Graph that on your scatter plot. So to do that, you're going to do the y equals, bars, statistics, EQ, reg EQ, graph. And then use this function to predict the average fuel consumption in 1998. I'm just going to go to my table because this is an X value. I've already graphed this in there. Go to my table and I'm going to go down to 15. we are talking in gallons here. So that is 608.78. You can leave like that. I hope that this is helpful and at least comparative to what we do in class. If you have questions, please email them to me. Work on your practice and homework. Let me know what you need from me. I'm going to upload the keys. Bye, guys. Have a great day.